If you think the whole idea of an elevator to space sounds like science fiction, you're right. It was popularized in the late 1970s in a sci-fi novel called The Fountains of Paradise by Arthur C. Clarke.
At last, we can build the space elevator, and then we will have a stairway to heaven, a bridge to the stars.
But as long as people have dreamed of building that bridge to the stars, no material existed to make a cable that's strong enough. That is, until we found that one of nature's most common atoms, carbon, was leading a secret life.
I wouldn't say carbon is promiscuous. I would just say it's very open-minded.
Carbon atoms just love to form extremely strong chemical bonds with one another. We knew they could be arranged in a lattice to form diamond, or in sheets to form graphite. But until recently, we had no idea they could also form tiny spheres called buckyballs, and tiny tubes called carbon nanotubes. Much stronger and lighter than steel, and able to conduct electricity, these cylinders of pure carbon have been called a wonder material, a new building block that might be used in everything from electronics to airplanes. But as a space elevator cable, carbon nanotubes have some big problems. The longest ones ever made are only a few centimeters, and joining them together end to end, one at a time, is simply not practical. So how would we ever use these tiny tubes to make a cable that's 22,000 miles long? Deep in the heart of Texas, scientists are taking a different approach to assembling carbon nanotubes.
It's the dream of the future, but it's an achievable dream.
To make a batch of carbon nanotubes, bake a silicon plate coated with iron particles at 1,300 degrees Fahrenheit in a special oven. Then add a dash of acetylene, a gas that contains carbon. When acetylene comes in contact with the iron, it releases its carbon atoms, which assemble, as seen here, into nanotubes. When the plate comes out, it's coated with a black soot that contains trillions of carbon nanotubes, all aligned vertically in what Ray Bachman calls a forest.
Think of a bamboo forest.
But unlike a real bamboo forest, the trees in a nanotube forest tend to stick together, thanks to a faint force operating at the nanoscale, called the van der Waals force. It's sort of like magnetism.
So when you pull one nanotube out, you pull its neighbors, and then they pull out their neighbors.
Pulling a whole row of nanotubes from the forest on the left, they can draw out a ribbon of pure carbon nanotubes, held together by nothing but the van der Waals force. This ribbon is less than 1,000th the thickness of a human hair, and it's stronger than steel. But can nanotube ribbons ever be made strong enough for a space elevator cable?
That is an unresolved question. But in science and technology, I've learned to never use the word never.
Back in New Mexico, the mood is more optimistic as the second day of the space elevator competition gets underway. Among those hoping to claim NASA's $150,000 prize is Brian Turner, captain of a truly homegrown team, the Kansas City Space Pirates. Hoping to make their elevator sail up the ribbon, the Space Pirates pull out their secret weapon, 15 mirrors, each the size of a twin bed.
Well, one person in each mirror.
Beaming sunlight to your collecting mirror,
right,
to the solar panels,
right,
giving the energy to climb.
Right. Are you ready? All right, here we go.
Halfway up the ribbon, the wind kicks in again.
Gotta get up there. I'm gonna go look at it this way.
Bouncing in the breeze, the parabolic mirror can't stay focused on the solar cells.
Come on.
The Pirate's elevator grinds to a halt.
Come on.
If the wind hadn't been bucking, I might have been better off. But I can't believe I didn't make it to the top. I figured I could fight my way up there.
Next up, and favored to win, is the University of Saskatchewan Space Design Team, or USST for short.
Go time, right? It's go time.
Their secret weapon, a stationary mirror to reflect a spotlight straight up the ribbon to the solar array.
Go back a little bit. Hey, back. Phase one.
It looks like they'd make it to the top in record time, fast enough to claim the $150,000 prize. So they win?
We have to have a little discussion about that.
Before the prize money can be awarded, the remaining teams get one last chance. But will we ever take a ride in a real space elevator?
I think it's crazy, but I still think it's possible. And I think it's something that if we can do it, we should do it.
Well, one thing's for sure. We've got a long way to go before that happens. But who knows? Perhaps someday technology will catch up with our imaginations and take the space elevator out of the realm of science fiction once and for all.